video we're going to look at solving an equation with radicals, and this one's a little bit more challenging. So the idea here is we want to find out what value of x makes this equation true. So we need to isolate x. And we have a square root here, plus 5, and this 5 is not underneath the square root, equals x. So the first thing we need to do is get this x out from under this square root. We need to get rid of this square root. And what undoes a square root is a squared. All right, so we need to square both sides to get rid of that square root. But before we square both sides, we want to isolate the square root. We need to get the square root by itself on one side of the equal sign. All right, so we have square root x plus 7 equals x minus 5. Now we want to square both sides. Why are we squaring both sides? Well, we're squaring both sides so that we can get rid of this square root. The square root of x plus 7 squared just leaves us x plus 7. And that's good. Get rid of that square root. Now, this is where students run into trouble here on this right-hand side. I'm going to do this, let's do this in a nice purple color here. Purple. Oh, it doesn't want to give me purple. Okay, let's do this in purple to show what we wouldn't want to do over here. Some students take x minus 5 squared and they tell me that that is x squared. They do like this, x squared, and then they say negative 5 squared is plus 25. All right, that makes me sad. That's not correct. Why is that not correct? Well, we could show why it's not correct by putting in a number. What if we put the number 8 in there? 8 minus 5 squared. Is that the same as 8 squared plus 25? Well, 8 minus 5 is 3. Squared would give you 9. That's certainly not 8 squared plus 25. That's way more than 9. All right, these two things are not equivalent. Because when you square x minus 5, what that means is x minus 5 times x minus 5. That's what x minus 5 squared means. And in order to do this multiplication, you have to take everything in the first parenthesis and multiply it by everything in the second parenthesis. Some of you know this as foiling. So I'm taking x times x, x times negative 5, negative 5 times x, and negative 5 times negative 5. So to finish it off, we have that. All right, on the left-hand side, we still have x plus 7. So now what we need to recognize is that we have an x squared term. And when you have an x squared term, you have a quadratic equation, and you're going to solve those differently than you solve linear equations. Now, especially since we have an x squared term and x terms, we're going to have to set this equal to 0 and then either factor it or use the quadratic formula to solve it. So I'm going to get a 0 on the left-hand side. So I'm going to subtract x from both sides, and I'm going to subtract 7 from both sides. That'll give me a 0 on the left-hand side. And let's see, we've got x squared minus 5x minus 5x minus 1x gives me minus 11x. And 25 take away 7 is positive 18. Sounds right. Okay, so now I can see if this will factor. And if it doesn't factor, I can use the quadratic formula. Since there's a 1 in front of this x squared, this is what I call an easy trinomial. And all I have to do is ask myself, is there something that multiplies to be 18 and adds to be negative 11? And if there is something that I can put in these two boxes that makes this true, then it's factorable. Now this only works when there's a 1 in front of there, which in this case there is. So I'm thinking negative 9 and negative 2. Multiply to be positive 18 and add to be negative 11. So this is going to factor to x minus 9, x minus 2. Make sure you bring down your 0 equals. Oops, I don't want to do that. Now that we have this equal to 0, two factors equal to 0. We know two things are going to multiply together to give 0 only if one of them is equal to 0. So either that's got to be equal to 0, x minus 9, or x minus 2 has to be equal to 0. One of those two things has to be true for that product to equal 0. Then I finish solving these little equations, and I get x equals 9, or x could equal 2. Now, one thing you want to be careful of when you are solving these kind of problems is you can get answers, you can get roots that don't actually make the equation true. So we need to go double check and make sure that these two solutions actually work. So let's do a check. Let's check both of these. Let's start with x equals 9. So I'm going to plug 9 into the original equation where the x's were. 9 plus 7 under the square root, then add 5. What does that come out to be? So the square root of 9 plus 7 is 16, plus 5, 4 plus 5, 9, that's 9, which is supposed to equal x, which is 9. So that's good. Check. That one works. Now let's check x equals 2. So I'm going to put a 2 wherever there's an x. So I get the square root of 2 plus 7 plus 5 equals 2. So the square root of 2 plus 7 would be 9, which is 3, plus 5. Uh-oh, that is not 2. Interesting. So this can happen when you square both sides. You create extraneous roots. So that means we have to come over here to this 2 and say, sorry 2, you do not work. So going through this whole algebraic process gives you possible solutions. It narrows it down. I mean, from the beginning, we didn't know what the value of x was. We had no idea. At least going through this process, we had it narrowed down to 2 possible answers. That's pretty good. I know a lot of students don't like the fact that one of them doesn't work. But if you can get it narrowed down to only 2 to check, that's pretty good odds. All right, so 9 is our solution. And we know it works because we checked it. And that's how you solve these kind of equations. So just make sure you isolate the square root before you square both sides. And then be careful when you have a binomial squared that you actually FOIL it out. And if you do those two things on these kind of problems, you should be solving these equations like a pro.